Today I'm going to tell about the regression and technologies. So first of all, let us understand that what do you mean by the regression and what do you mean by classification? Actually, regression is used to, predict something when you have some variables, independent variables, and you want to predict one variable depending on these independent variables, right? For example, you have the say employee salary. You want to find the salary of an employee, right? And it is if you want to find the salary of an employee, it is dependent on various features. What are the parameters? It may be dependent on the the position or the designation of the employee. It may be for the in what level they are. That may be the one parameter. It may be the in which department they are working. That may also differ. It may be the age that can affect. It may be the experience that may affect. So there may be the various parameters with which the salary of the employee depends. So if we want to find the salary of an employee, that is known as your dependent variable, and that variable is dependent on the which variables, for example, age, for example, type of work, for example, the department name, for example, their designation, for example, their the experience. So all these things will be the independent variables. So regression is basically we do when we want to predict something dependent on the some variables, independent variables. Next term is your classification. When we do the classification, we do the classification depending on some parameters, of course, but we want to classify. In which way we want to classify? For example, we want to classify a person that whether it is a male or whether it is he is a male or whether she is a female, male or female, right? Like because of some parameters, we divide or the classify them male or female. For example, cat or dog. So we want to classify whether it is a cat or whether it is a dog. So these are the classification algorithms. Now we will see that in healthcare, why how it will differ, right? For example, in healthcare, say some person it is coming with a cancerous growth, right? So you are defining that whether the cancer is whether it is a benign or whether it is a malignant. So this way you can classify them. So those type of applications are known as your classification algorithms. But when we do the time series, applications, that time we can just see that can be the regression application, right? So we will see the difference, right? Okay, right. So if we say that, what do you mean by the introduction to regression? What is regression? That I have told that regression is the regression analysis. What do you mean by that? That is a term, statistical term. It is a statistical term. So it is used to model the relationship. Now we say that regression model. So what is the function of the model, right? I have told the term regression. Now what the model will do, model will find the relationship between the dependent or the independent variable, dependent and independent variables. And the relationship is how much accurate you are finding the relationship. That is actually the model accuracy. That depends on your calculation, that how accurately you can find out the relationship between the dependent and the independent variables. That is actually the modeling. In the accurate way you can find out the model, the accurate you will find out the you can find out the result. So regression analysis helps to understand how the value of the dependent variable is changing, right? Corresponding to the independent variable when other independent variables are held fixed. For it, what is the meaning of this? Meaning is this, for example, you have many independent variables, right? So if one independent variable you are changing and you are finding the change in the dependent variable when the other independent variables are fixed, right? Age, it is fixed, or age you are changing and the other variables you are keeping fixed. For example, salary you are changing but other variables you are fixing. So like this, regression will give you the that how this dependent variable is dependent on the other independent variables, and the what is the strength of the dependency that it will be given by the regression model. So if I say the regression model, so regression model, as I have told, that it will give the relation between the variables where changes in some variables may explain the changes in the some other variables, right? So independent variables are known as your explanatory variables. Explanatory variables are termed as the independent variables, and the variables which are to be explained, these are known as your dependent variable, right? So regression model, what it gives the size of the relationship, it gives the strength of the relationship. Also, it can give you the significance, right? Statistical significance, p value, r value of the relationship. That we will see that what are the parameters of the regressions. Now, as I have given the example that for employees data, for example, the dependent variable is employment income, right? Employees income, and the independent variables may be hours of work, maybe his education, maybe his age, maybe the region, right? Where he is working, years of experience, occupation, right? Designation. So these may be the independent variables. Similarly, if you say the price of a product and quantity produced or sold, right? In both the way you can find out. One example is your that quantity sold affected by price. That means here quantity is your dependent and it is affected by price means price is independent. That means the quantity of the product that is sold, how much it is affected by the price. If price is less, then quantity, the selling number of the quantity is how much, and the if the price is more, then how it is affecting the quantity sold. Or in otherwise, the price affected by quantity offered. That means if you are offering more quantity, then how it is affecting the price, or if you are offering the less number of quantity, then how it is affecting the price. So this way you can just see when you go to market. So that is actually the strategy, what they find out, that if you take the 3 clothes, then 40% discount. If you take the 2 clothes, then 35% discount or 30% discount. So that is their strategy. So with the help of this regression analysis or the regression model, they do the strategies, right? Now, for healthcare analytics, where we can use, for example, I have given that if you want to find the hospital, quality and the safety, depending on the patient volume, depending on the healthcare cost, depending on the, patient outcomes. So, depending on this, you can find out that what is the quality of the hospital or the safety measure of the hospital. Like this, you can use this regression analysis in healthcare. We will see one example also in detail. So here is a simple example that I have given, that everybody, that if you do the advertisement and how much sales we are getting, right? Similarly, year wise, for example, we have $90, the sales is your thousand, right? $1,000 sales. Then if you are if you are giving that $120 only the advertisement cost, then you are getting the sales amount is $1,300. Like this, if it is telling that if the advertisement cost is $200, right, then I want to know that what will be the prediction of my, sales for this year. So all these things, such type of things are the regression analysis example. So before the example of healthcare, let us see that what is the main terminology of the regression that you want to know. Dependent variable, that I have told, dependent variable are known as your target. Independent variable are known as your predictor, right? These are the two terms we use technically. One is your target, another is your predictor. Target is your dependent variable, final exam, final value or the final variable or the target variable, and the independent variable are the to which the target is dependent, right? That is known as your predictor. Another terminology we use when you will do the in Python programming, Jagriti, will they do the in Python also?
Yes, ma'am, they'll be working with Python itself.
So when you will do in Python programming, there you will see that how we can, remove the outlier. So outlier is one term that is used in machine learning very frequently. That is actually when you are seeing the observation, right? If your value is very low or if your value is very high, that means those are the outliers that it should be avoided. In your data set, it should be avoided first. That is actually to how you pre-process your data, right? Pre-processing, that we see tell as a pre-processing of the data to remove the outliers, right? For example, age, right? Everywhere you are getting that 50, 56, 40, 46 or 30, 31. Suddenly you are getting 114. That means this is an outlier, right? Similarly, it may be very low also. Somewhere you are getting all the official employees data, somewhere you are getting 12. So that is very low. So that is the outlier value and it will affect your modeling. So in the pre-processing only, that should be removed. Another one is your multi-collinearity. If the independent variables are highly correlated, how the independent variables are highly correlated? For example, there are two variables you are taking, two fields you are taking. One is your date of birth, right? Another is your age. So date of birth and age, these are, simultaneously it will affect the effect of date of birth will be similar as your effect of your age. So these are highly correlated. So if the independent variables you find such type of correlation, then you remove, right? One variable only you have to keep and the other variable you can remove. It should not be present in the data set, right? Otherwise it will affect, right? These are some terms you have to check. Another term you should know, one is your overfitting, another is your underfitting. If your algorithm works very well with the training data set, but you are not getting the good accuracy with the test data set, that means your problem is overfitting, right? And underfitting means that your data, when you are performing your algorithm, right? It is not giving the good result with your training data set, in fact. So that is known as your underfitting. So these are some terms: underfitting, overfitting, then outliers. So these are some terms that we use in case of the machine learning. So types of regression that we say, one is your linear regression, polynomial regression, support vector regression, decision tree regression, random forest regression, and some regression analysis we use for some algorithm actually we are using for classification. So here we will do some types of regression. For example, we will do linear regression, we will do polynomial regression, we will do decision tree, right? And some logistic regression, though it is named as your regression, but it is used for classification, right? Similarly, support vector also we can use, random forest we will use for the regression, that we will see one by one. So first you see that linear regression, right? So linear regression, if you want to see, I will just remove here, right? So linear regression, if you want to see, linear regression is a statistical regression method which is used for predictive analysis, right? It is a statistical regression. And when we are telling that linear means it gives a linear relationship. That is, linear means that is a line, right? Straight line relationship, right? So the straight line will be the straight line also, how it will, your aim should be, the straight line should be very accurate, which will, will be nearby the all the points that you have in your space, right? That should be your aim, right? So it is used to for solving the regression problem, and linear regression shows the linear relationship between the independent variable and the dependent variable. For example, you have the change of or the salary with the help of the age. If your age is increasing, your salary is also increasing, right? So that is actually linear relationship. So such type of points we use in the linear regression analysis. So if there is one input variable, only x, and the output variable you want to calculate, we say that is a simple linear regression. If there are more than one input variable, we say that is a multiple linear regression. This is the example of the linear regression. So what is the in your space, right? In your space, that is, what is your space? X or Y space. There are two variables we are giving, X or Y, right? So in the X side, we are giving the experience. In the Y side, we are giving the salary, right? Now we have many values depending on the employees data. We have many values that we have shown in your green color, right? Now somebody is asking that you have to prepare the regression model of this. The data, it has been given to you, and somebody has told that you have to find out the regression model for this. So what is your aim, right? Your aim should be to find out a linear relationship between salary and experience, so that it is very near to the all the values. Now linear relationship, it may be anything, right? If you say that, okay, let me use this one. Right? If you say, for example, one linear relationship, if I getting, say, for example, I am, sorry, just one. Yes. So if you are saying, for example, I'm drawing, say, oh, yeah, yes. So if I say, I can draw the line like this also, right? I can draw the lines this way also. I can draw the lines here also. Everywhere I can draw the linear lines, right? This is all are the linear relationship. But our aim should be that you have to find out that line which is similar or which is very nearby all the points. It should not be like that. This is only nearby, only one point. It should not be like that, right? So our aim, the regression, to find out the regression model is this: to find out a linear relationship or the line equation such that the line is very nearby to this all this point. That means it is best fitting the all the values, right? Now how to find out? What is the function of to find out the line relationship? We say y is equal to mx plus c, right? M is your slope and c is your intercept, right? This is the equation of the y is equal to mx plus c. So this is actually c, and this is your slope, that is your m. This is your y and this is your x. So our equation is your y is equal to mx plus c. Here also, for the equation, we will do like this only. We will use, for example, beta naught x plus beta 1. Beta 1 will be your slope, will be the intercept, and beta naught is your slope. right? Slope is this one. This is your slope, and whereby it will cut, this is your actually the intercept. If it is cutting the origin, that means your intercept is 0, right? So here also we are saying that the mathematical equation will be y is equal to beta 1 x plus beta naught. So y is equal to the dependent variable, x is your independent variable, beta naught and beta 1 are the coefficients. That means what should be your aim? Your aim should be find out the beta naught and beta 1 such that your line should be best fitting to the all the points. That is your aim to find out the model, right? Now how to find out? So beta naught, as I have told, so this is the main response when the x is equal to 0. That means actually the y-intercept, and beta 1, yes, beta naught is your intercept and beta 1 is your slope, right? So beta, our goal is to find out the values of beta naught and beta 1 so that it matches all the the values in the space. That means how to find out? That means you have to find out that less value of the sum squared error. That means you have to find out the error, and if your error is very minimum, that means you can say that my model is perfect. Now, how to find out the SSE or the sum squared error? Sum squared error formula is this, that SSE equal to the summation of I is equal to 1 to n. What is I is equal to 1 to n? These many points, these many values, these many data, right? If you have the 10 values, that means I is equal to 1 to 10. If you have the 50 values, that means I is equal to 1 to 50. Next is your yi minus yi bar. Yi is your actual value, right? And yi bar is your whatever you are calculating. Now here let us see that what is y and what is yi bar. For example, if we are drawing this line, right? This line means there must be some beta naught and beta 1. Let us see that our beta 1 is equal to, say, for example, 0.5, say 0.5, right? And beta naught equal to, say, for example, 1.5. So our equation will be y is equal to, we are telling the equation is like this, beta 1 x plus beta naught. That means we are telling that y will be beta 1 x, that is 0.5x plus beta naught means 1.5. Now, wherever you have this y value, actual, for example, for this, you want to calculate, right? So this is y dash, if you, for this point, right? For this point, if you want to calculate, so for example, the actual value it is giving, say for example 0 to 40,000, say 35, right? Actual values is 35, and for this you want to calculate, so y is equal to, you are calculating something, right? That time actually your this value will be more, beta 1 and beta naught. So we are calculating, for example, 0.5 into x. X is your, for example, in this case, right? At this point, right? We want to calculate at this point. Say this point, the actual value is this, but in our case, on the line, which is the value that we are calculating? 0.5 into, say, 1 is your experience, or 1.5, say this is your experience, plus 1.5. Like this, we are finding some y. So the SSE that will be calculated, y minus y dash, this is my y dash. So y minus y dash whole square, right? And for each value, we will calculate this and after that we will find out the SSE, that is yi minus yi dash bar whole square. So for each and every point we will calculate yi minus yi dash. So yi is what? That is given in your data set, and yi bar is what? That you are calculating from your model, right? So when you will see that SSE is very less, or for example it is getting say 0.0001, that time you can say okay, my model is perfect, right? So that way you can find out that the best model for your regression. Now, how to find out beta naught, beta 1 and beta naught? That also the researcher has given. So the researcher has told that if you want to calculate the beta 1 and beta naught, then you can find out like this. That is your xi minus x bar. X bar is actually that is your mean of x, mean of x. Yi minus y mean, xi minus x mean whole square. Now, what is x bar? That we will see. And beta naught is equal to y bar minus beta 1 into x bar. This dash means these are the mean of the values. Now let us see with one example. So this is one example corresponding to your healthcare. To predict the length of stay of patients, that is known as your LOS, based on their clinical and demographic characteristics using multiple linear regression. When we are telling the multiple linear regression, that means y is equal to beta 1x plus beta 2x plus beta 3x. There may be x1, x2, x3, x4. There may be many, the independent variables, right? How many variables we are taking, that is our point, right? Now, this we have to calculate, that is your LOS in measured in days, right? What are the variables that we can see? Our dependent variable is y, that is your length of stay, that is your LOS. That means number of days the patient stays in hospital. And this LOS is dependent on which variables? It is dependent on age, that is age of a patient. It is dependent on severity score. That means clinical severity is what? 1 to 10 scale. Number of comorbidities. That is count of existing the chronic conditions. If you are from the medical side, you must be, knowing better than me, right? This is your count of existing chronic conditions. Admission type, that means emergency or the planned, or the lab value, that means CRP value, if you want to calculate what is their C-reactive protein level, right? These are some variables we are taking, and we want to calculate the LOS of a patient or patients in the hospital. So how to calculate? So our regression is your LOS equal to, I have told you what was the calculations, what was the functions, that is your beta 1x plus beta naught. And here we have the more than one variable. So our regression model will be beta naught into beta naught plus beta 1x1, beta 2x2, beta 3x3, beta 4x4. What are the so many variables, the number of variables we are using, the number of x also, it will be increasing. So in our case, it will be beta naught plus beta 1 into age, because our age is your one variable, beta 2 into severity, beta 3 into comorbidities, beta 4 into admission time, beta 5 into CRP plus epsilon. Epsilon we have taken the error term. For the time being, epsilon if you remove, you can remove also. So this is the data set you before you, it is there, right? There are, for example, 5 patients. Similarly, you have the data set maybe 40,000 patients. So for the 40,000 patients, if you calculate, automatically your model will be much accurate, right? So here only we are seeing that how to calculate, right? So we are taking the 5 patients age, 5 patients severity, various data, comorbidities, right? Depending on the count of the complexities, and then after that, the admission type, whether it is a emergency or whether it is a planned, we have taken 1 is your emergency and 0 is your planned, CRP values and the LOS values. It is given because it is a supervisory model, right? You must be knowing that the unsupervised, supervised, and the reinforcement learning. These are the three learning methods of the machine learning. So it is a regression is a supervised model. So that's why we have given the target. Target is already there. These are my Y, right? These are my Y. So LOS, what is given, that is my Y. And with the value of this, what we will calculate, that will be my Y dash, right? So what is my estimated this? I have taken the values. You can calculate these values. How? That I have shown you how to calculate. For example, beta 1 you want to calculate xi minus x dash into yi minus y dash divided by summation of xi minus x dash whole square. Let us see how to calculate this. You will calculate, you will calculate like this. Now, for example, for age you are calculating. For age, xi is your 45. What will be your x bar? X bar, that means this is mean, right? Or x dash or x bar. So what will be the x bar? It will be same for everything. 45 plus 60 plus 30 plus 72 plus 50 divided by 5. So something will be here x dash. And 45, when we will calculate, this is my xi, this is xi, this is also xi, we will calculate one by one, right? Similarly, here this 1 value is your yi, right? What is your y bar? Y bar will be 7 plus 12 plus 4 plus 15 plus 6 divided by 5. So how to calculate beta 1? This is my beta 1, that is your for age. How to calculate beta 1? I have told beta 1 is equal to, what is the xi minus x dash, summation for this 5. So what will be the summation that we will calculate? So 45, this is my xi, right? This is my xi. 45 minus x dash, that is summation. For example, this is my, say, 55, right? Here y bar, for example, say 12, right? Anything, whatever calculation. So 45 minus mean, that is your 55, right? Into yi minus y bar, that means 7 minus 12, right? Plus, why? Because this is a summation. Next one, that is 60 minus 55 into 12 minus 12. It cannot be 12. That means it may be the some other value. Maybe this average, it is coming, say, 13. Otherwise, it will be 0 here. So maybe we are taking as a 13, right? So next, again, plus 30 minus 55 into 4 minus 30. Like this, you have to plus for all the values. Divide by, it was xi minus x bar whole square. That means 45 minus 55 whole square plus 60 minus 55 whole square plus 30 minus 55 whole square plus 72 minus 55 whole square plus 50 minus 55 whole square. So when you will calculate all these things, you will find out the beta 1. Similarly for the other variable. Like this, we have calculated beta 1, beta 2, beta 3, beta 4, and beta 5. Right? And how to calculate beta naught? That also it has been given. Y bar minus beta 1 x bar. That means if it has the more than one variable, so minus beta 2 into x bar minus beta 3 into x1. Say for example, this will be x1, x2, beta 3 into x3 bar minus beta 4 into x5 bar. Bar means mean, right? Like this, you can calculate the beta naught. right? You can calculate the beta naught. So we have calculated the beta naught, beta 1, beta 2, and we have found out that estimated regression output is what? 1.5 plus 0.03 into age, 1.2 into this, 0.8 into this, 2.5 and 0.5. Now let us see what do you mean by these values or the constant. For example, 1.2, what do you mean? What is the significance of these values? What is the significance? For example, age, we are getting the 0.3, 0.03. It means that each additional year of the patient increases LOS by 0.03 days. That means the significance is this, right? Say, for example, we are calculating, say, severity 1.2. What do you mean by this? 1 point severity, higher severity, that increases the LOS significantly. For example, comorbidities is 0.0, 0.8. That means each additional disease or the complexity adds the 0.8 days for the patient. Say emergency admissions stay 2.5 days longer, right? CRP values, higher inflammation leads to longer hospitalization. So the values it is meaning, that is actually you should understand that what do you mean by the constant, right? Beta 1, beta 2, what do you mean by this? That means each additional age, each additional severity, each additional comorbidities, each additional high the inflammation, right? How it affects the LOS. That means this. And after that, we calculate the R square. R square is your goodness or the fitness, that I will tell you in the evaluation matrix, that R square value. We calculate the R square. That means R square means that 82% variation in LOS explained by the predictor. That means 0.82. That means it should be nearby 1, right? So that means your regression value, your regression modeling is good regression modeling. Similarly, you can find out the p-value. If it is p-value is less than 0.05, that means variables are statistically significant. All variables are significant. That also you can calculate, that which variables or which features are significant, which features are not significant, right? Like this, we calculate the regression analysis. Any doubt up to this? Any doubt? If you have understood or if you have any doubt, kindly let me know that why we do the regression, right? One thing is this, and another is your the example, what I have given. Is it understandable to you? You can give me in chat also, so that I will just get to know that whether you are understanding or not.
Ma'am, we have one query in the chat box that is
Okay.
about how to calculate R score that they need to know again.
Okay, art code we will see. We will see in the end of the slide. I have given all the performance matrices. We will see R2. Yes. R square we will see. Yes. Any other doubt? To understand you have got the concept, that is most important. Yes, yes. The R square, no. Here we have calculated, right? Here R square we have calculated. Now for the calculation, some equation is there. So that equation I will tell you, right? Otherwise, equation is same. It will be different for the different model, because sometime R square will be less. That means your model is not good. Sometime R square will be good. That means you can say it is nearby 1. That means you can say that it is good fit, right? So that way you can calculate, right?
Good evening, ma'am. Good evening, ma'am. Is the model, the concept is same for all type of regression, or it differs with each type?
No. It will be same. It will be
Thank
same. Yes, it will be same for all types of regression. It will be same. It is the parameter for the regression analysis only, right? Any type of
Okay.
regression,
Thank you.
right?
Thank you.
Okay. Okay. So let us see, next is your polynomial regression. So polynomial regression, it is telling that you know that what do you mean by polynomial, right? Polynomial is what? That we can say, what do you mean by polynomial? Just say a1x plus a2x square plus a3x to the power cube. So these are your polynomial expression, right? So here also that if your variable, dependent variable is dependent to the independent variables in exponential terms, then we can say that is a, the polynomial expression, right? Higher degree terms, right? Not only the single term, only degree is 1, the degree may be 2, degree may be 3, degree may be 4. That time we will use the polynomial expression. That we say that is your non-linear relationship, right? Between the target and the input features, right? Now let us go to the decision tree algorithm. I will just again remove this one. Yes. So if I say the decision tree algorithm, this is also one of the important, regression analysis algorithm. So decision tree, by name only, you can understand that what do you mean by this. It can take the decision, right? The model can take the decision. That means whenever you want to take any decision, that time you have to use this decision tree algorithm. Now, what is the decision? For example, decision you have to take whether the patient has to be taken in surgery or not, right? Whether the patient has to take this drug or not, any type of medicine or not, right? Like this, if you, for example, in marketing analysis, if I say when the in June and July, right, when the vacation period is there, that time whether our market strategies will be the cost of the clothes will be less or will be more. So like this, if you want to take some decision depending on some data, that time we use this decision tree algorithm. And what do you mean by tree? Tree means that it will be a root. Mainly it will start from the root, and after that it has some branches, right? And it can have many branches depending on the decisions, whether it is greater than 1, whether it is a less than 1. If it is a greater than 1, then whether it is a some yes or no, whether it is positive or negative. Like this you can calculate, you can make the decision depending on your outcomes, and we can say these are the branches. And final decision, whenever you are reaching one by one, level wise you will be reaching, at the end whatever decision you are taking, that is known as your leaf. Leaf is the ultimate, right? Whenever you are getting the leaf, that means after that you cannot take the branches from the leaf. That is the ultimatum, right? So it is a flowchart like tree-like structure, right? Internal node, I will tell you that what is the disadvantage and advantage, right? Internal node denotes the test on an attribute, because depending on the attribute only it will make the branches, right? Branch represents the outcome, as I have told, and leaf nodes basically the class distribution. That means finally when you are getting to the class, when you are taking the decision, that is actually the leaf nodes, right? Now whenever we want to construct the tree, first of all we start with the root. That means all the training data set, training examples, it will be in the root. And after that we will separate the training data into the different branches with the help of the selected attributes, right? Sometimes we use this pruning. Pruning, you know that we do the pruning, right? Pruning is your cutting the branches, right? Cut the branches. So here also we remove the branches. Here also we identify the branches or the values which affect our data, which affect our model, which reflect the noise, which reflect the outliers. So those values we prune, either pre-pruning or the post-pruning. For example, pre-pruning in the sense that before the pre-processing, when you are doing the pre-processing, then only you are cutting those values. These are known as your pre-pruning. When we are after making the tree also, you can remove some branches. Whenever you see, oh, these branches are not, effective, so we have to remove that. You can remove that, is known as your post pruning, right? Like this we have some type of methodology to do the pre pruning and the post pruning in the decision tree algorithm. Now here example is your that we can do for medical diagnosis, we can do for some other analysis, market analysis, credit risk analysis, some classification, right? The object classification, that also we can use. And here sometimes we have the target values are discrete values, right? Sometimes we can get the target values are the continuous values also. For example, let me just tell you one time. This is actually the voting. So discrete example, for example, that weather prediction model that predicts whether or not there will be rain on a particular day. So this is discrete, right? Yes or no. Whether there will be rain, yes, and there will not be rain, no, right? That may be the also one example that we can use for the decision, right? Also for the continuous value, where when our dependent variables are the continuous, it is giving the continuous output. What is the continuous output? For example, profit prediction model that gives us the probable profit that can be generated from the sale of a product, right? So you are getting the decision tree. You can find out with the decision tree regression model that sale of a product, how it is giving the profit, and can you do the prediction of a product, prediction of a profit, right? Or depending on the selling value of a product. So that time also we can do the decision tree regression model. Every time you cannot do the linear regression, because you do not know that whether your relation is your linear or not. But where your values data, when you will put it, and if you find it that is a linearly distributed, that times we do the linear regression. But when it is not linearly distributed, that times you can take out with the decision tree model or the random forest model or some other model, right? So for example, this is actually the decision tree. This is an example, right? Salary is between, for example, we want that accepted, offer should be accepted or offer should be declined, right? So there are some parameters. First parameter we have selected that salary is between 50,000 to 80,000, right? Yes or no. If it is yes, then only we will go further. If it is no, we will decline, right? So that way we have classified that it is the declined offer. If it is yes, then again we will split. How we will split? We will split the data like this, that those data which where we can get our office near to home or not, right? So if it is near to home, then only we will see. If it is not near to home, then we can decline. Then again, it can provide the cab facility or not. If it is yes, then only I will accept. If it is no, then only I will decline. Like this, one by one step, you will go further, and finally you can get the result whether it is an accepted offer or whether it is a declined offer. Now let us see with the LOS only in the decision tree regression model, how you will calculate that. Already we have done something. in the regression, linear regression. So here, this is the same data, that is your age, severity, comorbidities, and admission type and LOS you have to find out with the decision tree algorithm. Now, these are your model inputs and model outputs. Model input, as I have told, age, severity, this, admission type, right? These are my input features, and the output features is your LOS. That means final length of stay I have to calculate, right? So let us start from the first. So first concept is this, that in decision tree regression, you have to split the data. You have to split the data into region. Now, whenever you will split the data, you have to find out the best split. So that's why it is known as your greedy algorithm. Why it is known as your greedy algorithm? Decision tree is known as your greedy algorithm. Each and every step, it will find the best split, right? Maybe it may happen that whenever the whole model will be selected or whole model will be designed, that it may not be the best for the whole model, but for each and every step it will find out the best split, right? That's why it is known as your greedy, so that it is very greedy to find out the best split in each and every step. Maybe it may happen after making the whole model, it may not be the best model, right? That may happen. So first all the data, this all data with me, first of all, we have to select the best fit, right? We have found out the best fit as your severity score. So we have found out that best severity is best split, right? It is the algorithm only will find out, right? Now for the example I have telling you, so first I have found out that severity score is less than equal to 6. Now let us see that less than equal to 6. So what are the patient which is coming? Patient 1, patient 2, and patient 4, and patient 6, right? These are the 4 patients we have found out less than severity 6. 4 patient, right? Now we have to find out the next best split. What is the next best split? So we have found out the two. One is your severity less than equal to 6. Another is your severity more than 6. What is the more than 6? That we will see. In case of less than 6, we have found out the next level. Here we are finding that next best split is your admission type. Now let us see that what is the admission type. So we have the admission type is your planned or emergency. For patient 1, patient 2, patient 4, and patient 6. You can find out that for the 3, these are planned, and for 1 is your emergency. That means patient 2, it is emergency, and patient 1 and patient 4 and patient 6, it is planned. So let us come here. So here it is telling that planned, the three planned, one is your 4, another is your 7, another is your 3. What is the 4, 7 and 3? That is your LOS, corresponding LOS. 4, 7 and 3. That means patient 1, patient 4 and patient 6, right? And for emergency, that is your 8 days. That means only one data, and it is final that LOS will be 8 days. That means your admission type, if it is planned, then LOS should be something. If your emergency, admission type if emergency, then is your LOS equal to 8. Why it is telling LOS 8? Because if P2 is your emergency, then we have found out that if your severity score is less than equal to 6 and your admission type is emergency, then directly you are calculating your LOS is your 8. But if your severity score is less than equal to 6 and your admission type is planned, then there are 3 values. That time what you will do? You will do the average of 4, 7 and 3. That is your 4.7 days. That only here in this we have told. Here somewhere we have given, that is your Okay, here I have not written that is your average of this, the leaves, right? So if you get that's more than one values, then LOS will be the average of those three. So for this, we have found out. Now let us see that if the severity is greater than 6, there are two. Only is P3 is your severity 6, more than 6, and is your P5, that is 8 and 9. But in both the case, if you take the admission type, you can just see in both the case these are emergency. So it is not a best split type. So here, what is the best split type? We have taken the comorbidities is less than equal to 3. If it is less than equal to 3, we are telling for the P3 and P9. So if it is less than equal to 3, then we are telling that it is LOS is your 40. If it is greater than 3, then we are telling LOS is your 18. So this way we have taken the best split is your comorbidities, that is less than equal to 3. Yes or no? Yes. If it is yes, then LOS equal to 14. If it is no, then LOS equal to 18. So this is your decision tree model. So depending on this decision tree, if a new patient comes, what is the advantage? Advantage is your prediction. If your new patient comes with some values of age, severity, comorbidities, admission type, then directly from this model, you can find out that what will be the predicted LOS of that patient. Right? Up to this, is it okay for the decision tree? Any doubt? Any doubt in understanding of the decision tree algorithm? So we have found out from the root, and after that we are finding with the help of the depending on the values, we are finding the branches. So all these branches we are getting to the lower level, because these are the very 3 or 4 variables. Maybe you have the data where the 12, 15 variables. There you may add the more number of branches, right? So that you can split very well, right? So after that you can find out your model. With your model, if any new person is coming, depending on this, directly you can find out the that what should be the LOS of that patient. Now if you have the more number of patients and the more number of data, right, automatically your decision model will be more complex also. But if you can find out the tree, right, for those patients, that it will be accurate also. So if you have any data, any difficulty, you can just tell me to understand the decision tree. So two things we have collected. One is your decision tree, another is your regression. I do not have much time, so I have to do.
Ma'am, we have few queries in the chat box.
Okay. Let me see. Close to 100 is better generally in percentage. You can target. अच्छा ये तो जागृति ने लिखा है. Okay. How do I decide to find out the non-linear relationship, ma'am? Depending on your data, right? How it is affecting data, you have to very well, you have to read the data, right? You can put the data in your space. You can, if it is the actually, whenever you will go to the Python programming, that time only you will find out that whether the data is your linearly spaced or not, and you can find out the non-linear relationship. For example, that is the environmental condition, right? With the help of the environmental condition, you are finding the cases of this cough, cold, or fever. So you have some data. So from this, you can find out that whether the data is linearly spaced or not. From this only you can find out that it is a linear regression model or not. In emergency also there are 3 patients, 8, 14 and 22 days. Still LOS is 8 days. No, actually what happened that in our model, when we are finding the model, we have found out with the severity case. So in case of severity, if it is less than equal to 6, if it is more than 6, then we can find out the comorbidities. My model cannot be perfect, right? If you want to be more perfect, you can take the other variables also. Here I have not given the other different models. For example, fields. For example, age I have not given. So you can find out that if your model want to be very perfect, you can take the age is also one of the splitting variable that you can do. Okay, again I should come here. Okay, okay. So will decision tree predict only values of the given target values? Yeah, it can predict target values that were never preset in the training data. Actually, what happens that if your LOS, sometimes we are getting the average of the LOS, right? What if we are giving? So sometimes it can give the values which is not in LOS. For example, that we have calculated the 4.7, right? So the average of 3 values, that is your 4.7. So 4.7 is not in your target, but it is getting the values. Yes, you can get, because sometimes you are taking the voting, you are taking the average. So of course you may get some values which are not there in your target values. Yes. How it is different from the linear regression? Basically, actually there are some different types of requirement, that where you have to use the linear, where you have to use the decision tree. Both the cases you can do, but decision tree has some advantages, some disadvantages. If one time you find out the decision tree, then your prediction will be much quicker, right? Much easier. But to make the decision tree is a very tough work if your data is more and more variables are there, more complexity is there, right? And another thing is since it is a greedy algorithm it follows, so the overall model, it may not be so accurate. That time we just say that is your overfitting. That means it is good for training, but it is not good for testing values. So the overfitting problem is there in case of the this decision tree. That's why we use the random forest. Why we are coming to the random forest? Because the random forest actually removes the problem of overfitting, which we find in case of the decision tree, right? You are very right that decision tree we will get we can use the linear regression, we can use the decision tree also, but depending on your requirement you have to use, right? But with decision tree also you may get some disadvantages, right? So we use the random forest. And what is the basics of random forest? Random forest is basically the combining many decision trees, and it takes the aggregate of the output of all those decision trees so that it can be removed. This overfitting problem is removed in case of random forest algorithm, right? So this is actually random forest. I will just remove this and I will bring this below. Yeah. Right. So people use random forest regression to predict the continuous values as a prediction of stock prices, time series, forecasting, sale price, prediction, right? Like this random forest is used, and it is less prone to overfitting than other regression methods, because it builds the multiple random trees, multiple decision trees. And after that, it takes the output from all the decision trees and then it averages the data. I will just show you that how it takes. So this is actually the random tree, random forest. So training data, decision tree, training data, decision tree, different training data, right? Decision tree. And after that, the output of all this decision tree, they take the averaging or the voting and then finally the prediction. And this training data also, they take the randomly. That's why the name is your random forest, right? Randomly in the sense, it is not like this that 1 to 100 it will take the training data 1, 100 to 200 it take the data 2, and 200 to 300 it will take the training data 3. No, it may take any data, 100, any data from the your training data, and it can train and it can prepare the decision tree, right? So this is actually known as your random forest, and that's why with the help of the random forest only, our problem of the overfitting or that what we were finding in decision tree algorithm, that is removed, right? Random forest also, the practically you will do, Jagriti will take care. So now these are some regression performance metrics you can just note down. One is your mean absolute error. It is very easy to understand. This is your yj, this is your yj bar. That means y is equal to basically the actual output values, y bar is your predicted values, right? So if you are calculating both the minus and 1 by n, that is known as your mean absolute error. Okay? Next is your mean squared error. That means yi minus yi bar whole square divided by n. N is your number of data points. If your data points are 1000, then it's okay. 10,000, then it's also okay. So each and every value you have to, this is, you do not have to do the manually. Of course, you will do the calculation wise. That means each and every time it will predict and it will do the calculation and it will give you the MSC values. And you will see that the MSC values is how much, and depending on this you can take the decision. So here we will do, you practically also you will do sklearn.metrics, and there you will use the mean squared error function. These functions are already there. RSME, that is your root mean squared value when we are finding the MSC, and if you are finding the root, that is known as your root mean squared value. This is your R square. So how to calculate R square? I have told you R square is equal to goodness or the fit. How goodly it is fit, that your data is fit, right? So your model is fit, right? That is actually the R square. So when we will do the R square, that is actually we are calculating 1 minus. 1 is your main point, right? Actual target is your 1, right? If your R square is 1, that is very good, right? Excellent, right? So if your R square is nearby 1, that is actually very good, excellent, and all these things. So how it is coming? Of course, it is be less than 1 every time. And here, what we are getting? We are getting yi bar minus yi, that is whole square. What is this? This is your mean squared error. This is your squared error, mean squared error. And this one is your variance. That means yi minus yi bar. That means from the mean value, if you are calculating yi minus y mean, that means you are calculating the variance of each value, right? So this is actually the variance, difference, and then square, that means it is variance. So if 1 minus this by this you calculate, then you can find out the goodness or the fit of a set of predicted output values to the actual output values. So if your R square values is nearby 1, that means your model, you have whatever you have prepared or whatever you have found, that model is perfect, right? So these are 3 regression performance metrics. So that is all about the regression analysis. So just a very quick review. So we have done the regression, about the regression model. We have seen that why regression and where we use the regression. Terminologies of regression we have seen. We have seen the linear regression, that how the linear regression will do, how it is calculating, how beta 1 can be calculated, how beta naught can be calculated, and how we have seen that with the help of some healthcare example, we have calculated that how the LOS can be calculated with the help of the linear regression. And same calculation we have given that in the case of the decision tree algorithm also, that how it can be calculated with the help of the decision tree. How can it be calculated? And random forest algorithm also I have told that what is the advantage of random forest algorithm and what is the disadvantage of decision tree algorithm, right? Why we use, and these are some performance matrices. So this is all about your regression analysis. Now let me start the classification analysis. I suppose that there is no problem about the regression analysis. Yes. Should I start the classification analysis? Understood. Very good. Understood. Okay, okay, fine. Thank you. Okay, now it will be more clear when you will do the programming in Python, then it will be more clear to you. Now, next is the classification algorithm. As I have told that classification, another algorithm is your clustering, right? So clustering you will do much in the other day. So classification is also the supervised learning algorithm. And here we use that, that is depending on the values, I will just this. Depending on the values that whether the what is the class, right? Yes or no, 0 or 1, the spam or not spam, it is a cat or dog, it is a male or female. Like this, you can make into the classes or the groups, right? It is a color, say for example, it is blue or green or red, it is fruit or animal. Like this, you can use the classification algorithm. Quickly, I will tell. So this is just an example that it is a circle or it is a triangle. So circle is a class A, triangle is a class B, and this line is actually basically separating them all, right? But every time you will not get such type of separation, linear separability you will not get, right? So that time what example or what algorithms you should take, we will see. So some cases of classification algorithms, as I have told, that drugs classification, for example, that you are already in the healthcare side, if you want to find any medicine classification, if you want to find biometric identification, I have told you the example whether the cancer, right? It is a benign or a malignant, right? Similarly, speech recognition, whether it is a male voice or the female voice, email spam or not spam. Like this, we use the classification. That time we use the classification algorithm. Most basic classification algorithm is your logistic regression, and it is a very strong classification algorithm also, right? Logistic regression, the example of the actually equation of the logistic regression is fx equal to 1 by 1 plus e to the power minus x. It is known as your sigmoid function. It is known as it is uses the sigmoid function. This is 1 by 1 plus e to the power minus x. This is the sigmoid equation. That's why we say that it uses the sigmoid function or the logistic function. Sigmoid or the logistic function, that's why the name is your logistic regression. So when we draw this function, so we get such type of graph. When we draw the function, we get the such type of graph of the sigmoid, equation. So here it is this is known as a threshold value. We say that if your value is above the threshold levels, then we say that it will be rounded, the classification will be 1. If it is below the threshold value, the levels will be rounded to 0. So there will be two classes. If it is the rounding to the threshold value, nearby to the threshold value, we will designate at those values as your 1. If it is very below the, negative, that is below the threshold, then we can say this is your rounded to 0, right? So such way you can find out the 1 or 0 classification. So there are three types of logistic regression. It can be the binary, pass or fail, multi dimensions also, ordinal dimension also. Ordinal in the sense low, medium, high, not the binary, not like this, ordinal value, order, right? Order, first, second, third, like this, low, medium, high. So these are the ordinal values. So let us take one example. We will understand better with the example. So to predict whether a patient has diabetes, yes or no, based on the clinical or the demographic factors, right? This is actually we have to calculate with the logistic regression model. So you must be knowing that some patients are given, so there are ages, BMI levels, some fasting glucose, blood pressure, family history, yes or no, and the target value it has been given, diabetes, yes or no. These are the supervised model, that's why the target value are given. So we have to find out the model. This is the data set we have been given. So we have to find out the model, right? Diabetes 1 means diabetic, 0 means non-diabetic. Family history 1 means yes, diabetes had, and 0 means no diabetes, right? This is the database we have been given. Now we have to find out the equation. So this is the equation I have given, that is your fx equal to 1 by 1 plus e to the power minus x. And what is x? X is basically that linear equation. Whatever you have done in regression, beta naught, but beta 1 into age, beta 2 into BMI, beta 3 into glucose, beta 4 into BP, beta 5 into family history. There are 5 internal independent variables that we have written. Now estimated value like this, here also there are some the equations are there, how to calculate the beta 1, beta 2, beta 3 and beta 4, that we have calculated in regression, right? Not same, these are different equations. So I am not coming to the equations because I have not much time. So for example, I have calculated beta naught is equal to minus 12, beta 1 is equal to 0.0 for some with the help of the equations, right? We have calculated the x, right? So if we have calculated the x, so this is my actually model. This is my logistic model. Now somebody is coming to you, model I have created, somebody is coming to you and you have to say with this model, you have to check, right, that whether the person is diabetic, very likely diabetic or not, right? So you are taking the detail that the age is your 52, BMI is your 30, glucose is your 150, BP is your 138, family history is 1. So how to calculate? First of all, you will calculate x. So what is x? X equal to minus 12 plus 0.04 into 52, 0.08 into 30, 0.06 into 150, 0.03 into 138, 1.5 into 1. And you have calculated that is x equal to 7.12. After that, you have to calculate the fx. What is fx? 1 by 1 plus e to the power minus 7.12. That will be linearly 0.999. That means after that, you will predict that patient is very likely diabetic. Now here you will take the threshold value. For example, if fx equal to greater than 0.7, then we can take it is a diabetic. If it is less than 0.7, then it will not be diabetic. That depends on you, right? You as a doctor, you have to define that what should be your threshold value, right? That you have to define. So this is basically the logistic regression model. With the help of logistic regression, this way we calculate the whether we predict that whether the patient is diabetic or not. Differently, that is actually diabetic yes or diabetic no, right? For example, if fx is 0.7 greater than 0.7, then you will say yes. If it is less than 0.7, then you will say no. That means there are two classes, whether it is a diabetic, whether it is he is a non-diabetic, right? Next is your decision trees. Just like we have calculated the decision trees for the regression, similarly, we can take decision tree as a classification. So here I have taken a different example, not the healthcare example. Just you will understand, every time we should not take the healthcare, we should take the different example also, just for a change. So here we have taken, for example, there are 7 persons, right? Decision tree, how it is calculating for the classification. So we have some data, student data, age data, credit rating data, and depending on the data, we have to give the classification that whether the person can buy the computer or whether the person cannot buy the computer, depending on the data, right? So first of all, we have started splitting. I have told you splitting with the help of the age, right? So I have split it with the help of the age, that if he is an youth, if he is a middle-aged, if he is a senior, right? There in the regression, we had taken the number wise because we did not have the such type of value may be different, actually different types of data, right? There we have got 0.3, 0.4, 3, 4, 6. So that's why we have taken less than equal to 6 or more than 6. Here we cannot say less than 6 or less than 1 or less than youth or greater than youth, because we have three values: youth, middle age or senior. So we have to take this way only. So after that, we have calculated that if it is middle age, then we have seen only yes. So our class is yes. Only one value is there, and this is telling that yes. If it is an youth, then we are taking four values. It is telling class two yes and two no. And if it is a senior, then we are taking one yes and one no, right? That means this is your final. This is yes. The leaf has been obtained here, right? Now, in both these two cases, we have to find out the leaves, right? Now, after that, we have again, here we have taken the four values, yes, yes, no, no. So after the age, we have taken the next one, that is your student, right? So let us take the, if it is a youth and if he is a student. If he is a youth and if he is a student. So there are three values we are taking. What? If he is a student, that we are taking the two values, that is your yes, yes. And if your youth yes and student is no, then we are taking no. So we are taking the two classes. One is your no. If it is a no, that means student is no, then we are taking exactly that class is no. But if your youth yes and your student is yes, then we are taking two values. Two is your yes and one is no. That means here also we are not getting the exact classification. We are in ambiguity, whether it will be yes or whether it will be no. In this case, we are getting exact classification. If it is a middle age, then we will take yes, he can buy. Another thing, we have found out the classification that if he is an youth and if he is not a student, then he cannot buy, right? That is another classification. But if he is a youth and if he is a student, then we are not getting the result whether we will take yes or whether we will take no. That time we will do the majority voting. We will do the majority voting. Why we will do the majority voting? Because the third field we have seen that it is not of the advantage, because all these are fair only. So we cannot do the classification depending on the credit rating. So here only we have to decide, because if you do the credit rating, then also you will get yes, yes or no, because all these are fair only. There is no fair and excellent, that, and depending on this the values will be different. So here we will take the majority voting. Here we have seen the majority voting is your yes. That's why your classification will be yes, right? That's why here I have not given their majority voting. I have told in this there also in case of regression, right? If there are values, then we take the average. If there are not values, then we take the voting, right? If there are values, for example, 3, 7, 4, then we will take the average of these three values that we have taken in regression. But here in classification, we cannot do the average. So that's why we are taking the voting, majority voting. Now, in these two cases we have done. Now, in the third case, that is your if is a senior, right? If is a senior, then we are getting the two, that is your no and yes. Now, in case of senior, again we are doing the classification in credit rating. So, if it is a fair, then it is no. If it is excellent, then it is yes. So, finally, we have found out this is the your decision tree model. Age, youth, student, yes, then yes. Student, no, then it is no. If it is middle age, then it is yes. If it is senior, then there are again two classes. One is your credit rating fair, then it is no. Credit rating excellent, then it is yes. So this way we find out the classification of the with the help of the decision tree, right? I suppose there is no problem of understanding this algorithm. Let me take the feedback quickly. You have understood the logistic regression as well as the decision tree for the classification. Is it okay?
Ma'am, we have one query in the chat box.
Is binary logistic regression used in the analysis of case control studies? Yes, you can. You can. Logistic regression, depending, again I am telling, depending on your data you have to use. Depending on your data, right? Yes, very good. Thank you. Binary logistic also you can use, because you see here I have given in example control case binary you can use, that is your 0 and 1, right? Binary classes you can use for the logistic regression. Yes, you can use for the control that, for example, if it is 0, then it will not fire for the some switching on a system. If it is 1, then only it will switch the system. Right, this you can, for the controlling operations you can use the logistic regression, right? I suppose I could tell you this logistic regression and the decision trees, right? Next is your overfitting that I have already told you that the problem is your overfitting in case of this. Now we use the naive Bayes algorithm. Now in case of naive Bayes, and just down it, yeah. So naive Bayes is very powerful algorithm, but it is a not very easy algorithm, but it is powerful algorithm and it works with the help of the probability, right? So for example, directly you can calculate from the training data. You need the probability of each class, right? For example, there are two class, yes or no, right? You have to know the probability of yes, you have to know the probability of no, right? And another thing you have to know, that is your conditional probability of each class given each x value, right? Now this you will understand this statement, you will understand with the help of one example. So this is sorry, first of all let me see the example, then I will coming to the equation. So this is the example. For example, weather and play, whether the person should play or not, right? Sunny weather, overcast weather, rainy weather. There are three types of weather we have given: overcast, rainy, and the sunny. And some data has been given that no or yes. So the frequency table we have drawn, right? No and yes. Overcast, if it is the weather is overcast weather, then we can play 4 are yes. If it is rainy, then 3 are no and 2 is yes. If it is sunny, then 2 is no and 3 is yes. So total how many no's? That is your 5. How many yes? That is your 9. So what is the probability of yes? That is your 9 by 14. What is the probability of no? That is your 5 by 14. That we have found out. That is why 14? 9 plus 5 is your 14. So probability of yes is your 9 by 14 and the probability of no is your 5 by 14, right? And the overcast, that means for yes and overcast, that is your 4 by 14, right? For yes and rainy, that will be 2 by 14. If it is, for example, rainy season, how many total values are there? That is your 5. The probability of rainy is your 5 by 14. Probability of sunny is your 5 by 14. Now, to find out the probability of this, that is your naive-Bayes probability, we have some parameters. What are the parameters? You just see. We have to find out the conditional probability. That is, this is known as your conditional probability. Conditional probability of any class corresponding to your input. Now, let us see here. What do you mean by this? Conditional probability of any class. Class means, for example, yes, for example, no. Corresponding to your input. What is your input? Maybe overcast, maybe rainy, maybe sunny. That means if you want to know whether somebody is giving the statement, yes, if it is a rainy weather, then you can play. If it is a rainy weather, then you can play. You have to tell whether it is right or whether it is no, depending on the probability. So if it is a rainy weather, that means your X is rainy. You can play. That means your class is your yes. That means here, when I will calculate, my C will be yes, X will be rainy. So this means the conditional probability. That means you are finding the conditional probability of a class depending on the input variable. Clear? How to find out? You have to find out Px by C. That means probability of the input corresponding to that class into P of that class divided by P of that input. Now, what is our class? P of yes. What is your P of yes? P of yes will be 9 by 14. P by X, that means it will be P of rainy. What will be the probability of rainy? That you have to calculate. That means 5 by 14. That is your probability of rainy, right? Similarly, probability of overcast, probability of sunny. Another thing we have to find out, that is your Px by C. That is probability of rainy conditional to yes. So what will be the probability of rainy conditional to yes? That will be 2 by 9. Yes is your total 9 and out of 9, 2 are rainy. So what will be the Px by C? That will be the P 2 by 9. So that way we will calculate the probability of the yes conditioning to the rainy season. Now let us see this thing. Okay, these are the steps we have found out, right? Now, for example, this is the problem. Can you just tell me? I have told you. Now the question is as I have told you, players will play. Players will play. That means yes. Class is yes. If the weather is sunny, that means we have to find out yes by sunny. Last time I have told you the example, yes by rainy. Now you have to find out yes by sunny. Probability of yes by sunny. Is this statement correct? Afterwards, we will see that statement is correct or not. First of all, I have to find out the value. So what is the P S by Sunny? Is equal to P Sunny by yes, conditional Sunny by yes, into P yes divided by P Sunny. Now, can you tell me what is your P yes? I have calculated P yes as your 9 by 14, right? Here we have found out P yes is your 9 by 14. Okay. P Sunny is your 5 by 14. How it is 5 by 14? P Sunny, that is your 5 by 14. That also I have calculated. And another is your P Sunny by yes. What is P Sunny by yes? Let us see. P Sunny by yes. P Sunny by is your 3 by 9. P Sunny by yes. That means how many yes are there in P Sunny? That is your 3 by 9. So we have calculated 3 by 9. So what will be P yes by Sunny? So you are calculating 0.33 into 0.64 divided by 0.36 equal to 0.60. Since it is a greater than 0.5, then we are taking it as a higher probability and we are telling yes, your statement is correct. So naive-Bayes algorithm calculates with the help of the probability function. Is there any doubt to understand or not? You can just tell me. This is your naive-Bayes. Yes, quickly. Yes, any doubt of आप बता सकते हैं समझ आ गया नेप बेस
Ma'am, I hope we can move forward. They are saying it is clear for now.
Okay, very good. Fine. Time is also there. Okay, let me move. Somebody has given something odds ratio. This is actually basically the statistical measure. Something it has gone up. Okay. So I have given some examples in healthcare. Oh, sorry. I have given some healthcare also, but I will just give you the PDF file of this PPT. You can just see it, right? I have calculated that whether the diabetes know the how to calculate and all these things. This I have calculated. So Jagriti, you can give it to them so that they can see the calculations, right? They will understand for the healthcare operations how can it be used, right?
Sure, ma'am.
So another is your K nearest neighbor algorithm. It is very simple. What we do, I will just come here. So what it does, basically, there are some steps. First of all, we say the K, number K. K is your number of neighbors. It can be 3, it can be 5, it can be 6, it can be 7. Nearly we take the odd values, right? 7, 9, 11, so that we can distinguish. Somewhere we can get 3, somewhere we can get 4, so that will be total will be 7. Calculate the Euclidean distance of k number of neighbors. Now, with the help of examples, I will tell. So this is the one new data point, right? So I have taken that k is equal to 5. So what I will do, I will calculate the Euclidean distance between this point and every other points from this to this to this to this to this, all the Euclidean distance of each and every point. After that, we will find that what are the 5 near distance points, right? That means the nearby points are how many 5 points, what are the 5 points which are nearby this point depending on the Euclidean distance. After that, we will see that, for example, there are 3 points here and 2 points here in the different category. And if the new data point is there and it is nearby to 3 data points, here it is the 2 data points. So I will make it a point. This new point comes to this category, that means category A. And if somewhere some points are there, that it will go to the category B, that means it will calculate the Euclidean distance, and again it will see the nearby points. It will calculate the how many points are there in different category, and in which category the more number of points are nearby to that new point, new data point, and that time that new data point will come to this category. So this way we calculate the k nearest neighbor algorithm. Another is a support vector machine. Support vector machine is a bit tough in the sense that it is not a linear line. It gives us the hyperplane. That means more than one dimensional space. If we want to calculate, then it is better that support vector machine we use, right? That means hyperplane in the sense n dimensional space if you have. Here we are saying the 2 dimension only, x1 and x2. If there are more than one 2 dimension, that times we use the support vector machine. That times we cannot say that this one linear line is separating. We say the hyperplane is separating. And these two nearby, the boundary values, these are known as your 2 categories, 2 values. These are known as your support vectors, right? So one is your positive hyperplane, another is your negative hyperplane, negative hyperplane. So this is also I have given with the help of this, with the help of the support vector machine, we can go for the diagnostic features. From the diagnostic features, we can diagnose that it is a benign or it is a malignant. So SVM classifier we can use. You will do it in the classification when you will do in Python. Directly SVM classifier is there, and if you have a good data, then it will designate that whether your whatever new data you are giving, first of all it will find the model, and afterwards when it will be testing with your test data, then you will find out that how accurately it is giving your the classification. Accuracy is 90%, accuracy is 95%. Thereby you can just see that it will designate the more diagnose, it is the more accurate features it will diagnose, right? Here also we have the metrics, performance metrics. Main metrics what we use, that is your confusion metrics. In the confusion metrics, we have 4 parameters. One is your true positive, false positive, true negative, and the false negative and the true negative. That way true positive in the sense that actually it is positive and your data is also predicted value is also positive, right? Negative is your, that is your actually it is your, originally it is your positive, but your data is coming as your false, right? False negative, that means it is negative and your data is also coming false, right? True negative is your data is actually negative, but your data, your observed value, it is giving as your true. That means ये गलत है, this is wrong. False positive and the true negative are in the negative side, right? True positive and the false negative, it is in the positive side. So depending on this, we have the accuracy, that is your TP plus TN divided by all the values. Depending on this, we have the precision. Precision is basically the number of correct documents returned by our model. Actually, what do you mean by precision? That is actually out of all actual positive, how many actually your model is giving the positive values. Actually, basically all the positives, positive in the sense this is your false positive and true positive, all the positives, how many actual positives, true positive your model is giving, right? That is your precision. Recall, actually basically the you can say out of all predicted values, out of all the predicted positive values, right? Predicted positive values, that means true positive and the false negative. What are the number of positives it is giving, right? So that is actually recalled TP plus FN. That means what? TP plus FN means, sorry, yes, TP plus FN. That means all the positive values. How many of you are getting as a actual positive, right? That is your recall. Precision actually the positive and the false positive. That means your predicted positive. That means you are predicting as your positive, but actually it is not positive. So that way you can calculate the precision. So specificity is just an opposite to the recall, that is true negative divided by Tn plus Fp, and depending on this we found out the F1 score as well as the ROC, that is the region of curve, and we can say the AUC, area under curve, right? AUC is calculated with the help of the TPR, true positive rate, and the false positive rate, right? Basically, it is the 1 minus specificity you can calculate, right? So this is all about your classification. So in today's session, I have just tried myself that to give you the just an overview of the regression and the classification analysis. I will send you the PDF of this files, and Jagriti can send you the PDF of this file so that it can help you.
Thank you
Okay.
very much for ma'am. You have given a very detailed explanation of everything, and I suppose even if they are beginner, they could have gone through every aspect very easily with your detailed explanations, and definitely they will be able to use it further in the remaining days of our course. So this is honor, ma'am, to have you on this second day of our workshop, and we all are truly benefited with all the content that you have provided to us.
Thank you, Jagriti. Thank you, participants. Okay, thank you so much. Okay.
So with these insights today, I hope if there are no further queries available, maybe we can wind up the session for the day, and we'll definitely have the hands-on sessions for this workshop from tomorrow onwards. We will be directly working on Python programming with variety of data sets from healthcare domain itself. So make sure you all attend tomorrow again sharp at 6 so that we can start on time with the hands-on analysis. Thank you very much, everyone.